Hi guys, welcome to my channel. So in this tutorial we will be proving these trig identities, that is expressing sine squared and cosine squared in terms of tangent squared. So how to go about expressing sine squared in terms of tangent squared or cosine squared in terms of tangent squared. So let's dive right into it. So the first one we know that tan of theta is equals to sine theta over cosine theta. Now we can express sine in terms of cosine and tan by using this this expression. To implies that we have sine theta is equals to tan theta times cosine theta. So what if we square both sides? So we can take the square on both sides. So it means we are squaring sine theta on the left hand side and tan theta cos theta on the right hand side. And this one evaluates to sine squared theta equal to tangent squared theta cosine squared theta. Now let's call this one equation, let's say A. Now we can use the Pythagorean identity. So using the Pythagorean identity of trig, we know that sine squared theta plus cosine squared theta is equals to 1. So cosine squared theta is equals to 1 minus sine squared theta. So we can plug this, can call this equation B, so we can put B into A. That means wherever you see cosine squared theta in equation A, you plug in 1 minus sine squared theta. So our equation A evaluates to become sine squared theta is equals to tan squared theta times cosine squared theta is 1 minus sine squared theta from the Pythagorean identity. Can simplify this one out. Sine squared theta is equals to tan squared theta minus tan squared theta sine squared theta. You can bring sine squared theta to the left hand side, multiply by tan squared theta, so that should be sine squared theta plus tan squared theta equal to, sine squared theta is equals to tan squared theta. You can factorize sine squared theta out because it's common. 1 plus tan squared theta is equals to tan squared theta. So next, divide by 1 plus tan squared theta, divide by 1 plus tan squared theta. So these cancel out, and then we are left with sine squared theta is equals to tan squared theta over 1 plus tan squared theta. So when you look at our expression here, that is just equal to the expression we wanted to prove. So that is how you express sine squared in terms of tangent squared. Now let's tackle cosine squared. So we are going to use our Pythagorean identity. So from our Pythagorean identity, cos squared theta plus sine squared theta is equals to 1. So in that case, sine squared theta is equals to 1 minus cosine squared theta. So it means cosine squared theta, we can just plug in 1 minus sine squared theta, we can just plug in 1 minus cosine squared theta into equation A. So we can call this equation C. Equation C. So our equation A was sine squared theta is equal to tangent squared theta times cosine squared theta. So that is sine squared theta is equals to tan squared theta cosine squared theta. So wherever you see sine squared theta, you can just plug in 1 minus cosine squared theta is equals to tan squared theta cosine squared theta. Can group like terms again. So we have 1 will be equal to tan squared theta cosine squared theta plus cosine squared theta. So 1 should be equal to, factorize cosine squared theta out, and you have tan squared theta plus 1. Can divide by tan squared theta plus 1 on both sides. Tan squared theta plus 1. So that leaves us with cosine squared theta will be equal to 1 over tan squared theta plus 1. So when we look at this expression, that is equal to the expression we wanted to prove from the very beginning. That is this. So that is how you express the sine squared thetas and the cosine squared thetas in terms of tangent squared thetas. This is one method. We have another method which is far simpler than this one. So we can do that by drawing a right triangle. So this is the second method, which is far simpler. So we can draw a right triangle. This is our right angle. We can put in our theta here. So we can let the opposite side be x. We can let the adjacent be 1. And this should be the hypotenuse. So the hypotenuse, we can find the hypotenuse. We can call that one r. So the trick here is to find tan theta. Tan theta is normally opposite over adjacent. Sine theta is equals to opposite over hypotenuse, and cosine theta is adjacent over hypotenuse. So we can use the Pythagorean identity here to find the length of r. So from the Pythagorean identity, the hypotenuse squared is equal to the sum of squares of the other two sides, the sum of square of the opposite and the adjacent. Adjacent is 1 and opposite is x. So r squared is equals to x squared plus 1. 1 squared is 1. So r squared is equals to the square root of x squared plus 1. So in place of r, we can plug in square root of x squared plus 1. Now let's find sine theta using this right angle. So let's find tan theta first. Tan theta is equals to opposite over adjacent. Opposite is x, adjacent is 1, so that is equal to x. Let's find sine theta. Sine theta is equals to opposite, which is x over hypotenuse. Hypotenuse is the square root of x squared plus 1. Last, let's find cosine theta. Cosine theta is equals to adjacent. Adjacent is 1 over the hypotenuse. Hypotenuse is the square root of x squared plus 1. Now that we know this, we can now find sine theta in terms of tan theta. So sine theta is equal to x over the square root of x squared plus 1. But we know that x is tan theta. So in place of x, we can plug in tan theta right from here. So sine theta is equal to x, which is tan theta, because tan theta is x, all over the square root of x squared plus 1. X is tan theta squared plus 1. And this simplifies to tan theta over the square root of tan squared theta plus 1. So you can just take the square on both sides to find our original proof. Tan theta over the square root of tan squared theta plus 1. Square this. So when you square the left-hand side, that becomes sine squared theta is equals to tan squared theta over square root of this to the square is tan squared theta plus 1. So this is the proof for sine squared theta in terms of tan squared theta. And that is equal to our original expression, the one we wanted to prove from the very beginning. Now let's see. Now let's use the same right angle to find the proof for cosine theta. We know that cosine theta is equals to 1 over the square root of x squared plus 1 from our right angle triangle. And we know that tan theta is equals to x. So our cosine theta is equals to 1 over the square root of x squared. X is tan theta squared plus 1. So cosine theta is equals to 1 over the square root of tan squared theta plus 1. So we can square both sides. 1 over the square root of tan squared theta plus 1 square here. So the left hand side becomes cosine squared theta is equals to 1 over tan squared theta plus 1. And this is equal to the expression that we wanted to prove. So these are the two methods. I think the second method is far simpler than the first method. So let me know in the comments which method you prefer. The first one using a formula or the identity that tan theta is equal to sine theta over cosine theta, and we arrive at our expressions nicely. The second method is using the right angle triangle to find tan theta in terms of x, sine theta in terms of x, and cosine theta in terms of x, and plugging in tan theta into the sine and the cosine thetas to arrive at the same answers. So these are the two methods. So if you find this video helpful, make sure to like the video, subscribe to my channel for more content. I will see you in the next one.